Okay, so we're going to move on. Second little set of notes. Again, it's going to be pretty relatively short. Okay, so time of death. So we're moving forward. This was the last part of what the person doing an autopsy would want to determine is the time of death. And we're going to talk about some ways they might be able to do that. Okay. So during an autopsy, the forensic examiner wants to determine when the person died. A time of death helps forensic detectives include suspects based on their alibis or location of the time. Much information goes into figuring out the time of death. So there's a lot of things to it, different things we can look at, but really the time of death is very important to be accurate. If we don't have an accurate time of death, we can't check their alibis, we can't check their locations. Like there's not a lot to go on after that if we can't get accurate time of death. So some of the three mortises that can help us tell time of death are livor mortis, which is death color, the color the body turns. I'm going to talk about all these more. So I'm just going to kind of blow through them. Rigor mortis, which is death stiffness, algor mortis, which is death heat. So let's break those down. So livor mortis, death color, that because literally it means mortis means death in Latin and liver means color. So death color. As a body decomposition begins, the blood settles in the lower parts of the victim's body. Red blood cells break and release hemoglobin, which turns purple as they spill out of their cells. Wherever these pools of blood settle, the skin takes on a purple coloring. So it's like dark red purpley. You can see in this image here, it's very dark. It's like a very dark bruise. The pooling of blood is known as lividity. So this process of the blood settling is called lividity. That's a term. Begins 2 hours after death. So about 2 hours after a person has died, if they are still in that same position, the gravity is just pulling it down, and this process is starting to turn the skin the color of purplish red. So between 2 to 8 hours after death, the color will disappear when the skin is pressed on. Meaning, so like in this case, see how they're pressing the skin and they lift their finger up and you can't see the color? Okay, like that. But after 8 hours, the discoloration becomes permanent. Okay. So basically, if a person is found 8 hours after, kind of varies. Some people like it takes up to 12 hours, but we'll say 8 on average. When you press down on it like nothing, like that is the color of their skin now. It's permanently changed. So temperature also affects livor mortis. Hot temperatures speed up the process. Cool temperatures slow it down. That's pretty much true for all the processes. So in a hotter climate, this is going to happen faster. In a cooler climate, this is going to happen slower. So it is an average. You really do have to know the temperature of what the body was going through to make sure you know what time the color is telling you. So livor mortis does not only help approximate time of death, but also can tell me position of the body during the first 8 hours of death. So during those 8 hours, as the gravity is supposed to be settling the blood, you can tell me what position they were in. So for example, if all the discoloration is on the front of the body, that indicates a person was laying on their face. They're laying face down. So all of the blood went to their face and started turning to colors. Discoloration on many parts of the body can show that the body was moved from one location to another. So it actually can tell me that their body has been moved around. If there's color all over, like if there's some color on this side of their face and there's some color on this side of their chest and there's some color on their side, then they have been moved and placed in different areas and the blood started to settle there. So that is telling you, obviously, something has occurred that would not normally supposed to be occurring for the blood to be moving around like that after death. Next one that we can use is called rigor mortis. So rigor mortis again means death. Rigor means stiffness, so the stiffness of death. So this is a person who is deceased, and their legs are literally stiff as a board, can't be folded back. That's just the position that they are in. So it's caused by a lack of oxygen to the cells and calcium buildup in the muscles, causing stiff muscles and joints. Now, rigor mortis begins in the head, so it starts in the head. We're going to need to know this process. It starts in the head about 2 hours after death and slowly works its way down the body and into the legs. Now, stiffness peaks at about 12 hours. So you get whole body stiff 12 hours in. As the cells dissolve, because again, we're going through autolysis, which means the breaking down of cells. That's what autolysis means, because you're going through decomposition. The stiffness will slowly disappear. So you don't stay stiff forever. It's just a process of stiffening all the way up and then unstiffening. So stiffness completely disappears around 36 hours. Now that could be a little less or a little more, depending on how hot or cold it is, but around, on average, 36 hours, and they're completely unstiff again. So a dead body that is not stiff has been dead less than 2 hours, so they haven't stiffened up yet, so they've been dead less than 2 hours, or more than 48, because that's like the longest it takes. If it's like a cold climate, more controlled, 48 hours, they're going to be fully unstiff. So it either tells me it's been 2 days or less than 2 hours. And usually from other things about their body, you could tell which is which. If they're still stiff, then we're in that window of 2 hours after to 48 hours after. Now, some factors that affect rigor mortis and really affect everything. So these affect all the mortises. So cooler temperatures slow the onset of rigor mortis. Warm temperatures speed it up. So the hotter it is, it always speeds up decomposition. Clothing on the victim can affect this. A naked victim cools faster, which slows down rigor mortis. So that means, so the faster they can cool down, the slower this process is going to go. So usually a person who was found in the nude would have rigor mortis set in a little slower than clothed. Illness can also affect this if victims died with a fever. So they were sick, they had a fever. The fever makes them warmer. Warmer speeds things up. So they experience faster rigor mortis. It's going to happen probably before 2 hours are up. Or if they died of hypothermia, so that's freezing, they're freezing to death, then it's going to slow the process way down. Their body's really cold. Sun exposure may also provide warmth and increase rigor. So if they're left outside in the sun, it's going to speed up the process. Also, if the victim struggled or exercised prior to death, they will likely have less oxygen in their body and also be warmer, again, accelerating the rigor. Oppositely, if someone is sleeping when they are attacked or die in their sleep, it will slow the rigor down. Overweight individuals usually have more fat, which stores more oxygen, actually, and causes slower rigor rates because they have more oxygen in their body. Okay, now algor mortis. So algor mortis is death heat. So mortis means death, algor means heat. So describes a body's temperature loss. So this is a really, probably the first thing they're going to do when they find a body is take their temperature and try to compare it to the surrounding temperature to figure out how much heat they have lost. And that should give me a pretty accurate time of death. So when a person is alive, the body maintains a homeostasis, a regular constant temperature. We're supposed to be 98.6. Now, not all of us are 98.6, but like we're close to it. After death, the body can no longer maintain this temperature, right? We can't maintain our homeostasis. So we start to cool down or heat up, depending on what environment we're in. If you're in a tropical rainforest, that's 121 degrees outside, you're going to heat up. That's more than 98.6. If you are in chilly weather, that's 40 degrees outside, well, you can't withhold your 98.6, so you're going to start cooling down. So to record the temperature of a corpse, forensic investigators insert a thermometer into their liver, or actually it's a rectal thermometer if they're just on site. And the body cools at a rate of about 1.4 degrees per hour immediately after death. Then it slows to about 0.7 degrees per hour after 12 hours until it reaches the same temperature as the environment. Okay. Now, for our purposes, we're going to kind of ignore the fact that we do go from 1.4 to 0.7. We're just going to use this formula in here. They're going to simplify it a little bit. So basically, they're saying the average is 98.4. Okay, so 98.4 average temperature. You're going to subtract the measured rectal temperature and then divide by 1.5 because that's how much. That's telling me how much temperature degrees we usually lose per hour. So approximate hour since death. So you'll take 98.4, subtract their temperature, divide by 1.5. That's how many hours it's been since they died on average. So once you have the approximate hours since death, you take the time it is, time temperature was taken, and subtract off those hours or count back those hours, and that is their estimated time of death. Okay. Now, we do have a little bit of complication with the fact that time is weird, right? Time is not out of 100 scale, like a decimal. It's out of 60 minutes, 60 minutes in an hour. So therefore, the decimal from the equation does not equal minutes. So like if you get 9.2, that doesn't mean 2 minutes. That's not how it works. It means 0.2 of an hour. So example, we're going to round up to our quarter values, just simplify it for ourselves. So if you get 0.22, round it to 0.25. So if you have 0.25, that means a quarter of an hour. Okay, well, 60 minutes an hour. So that means there's 15, that means 30. Then 15, that's 30 again. So our quarters, like 4 quarters in a dollar, the quarters of an hour are 15 minutes long. So if your answer is 1.25, that means 1 hour, because the 1.25 of an hour, so that's 25% an hour, which is 15 minutes. So it would be 1 hour, 15 minutes. If you get 0.5 or close to 0.5, that's what you round up to, that's 30 minutes, that's half an hour. You get 0.75, so that's 3/4 of an hour, so 15, because each each quarter is 15 minutes, you get 45 minutes. And if it's above 0.75, just round it up to the next hour. Okay, so we're just going to keep it at quarters to keep our life more simplified for what we need. So here's an example. So this person's temperature was 90.9 when they took their temperature. So they've went down that much. We take that, subtract it, get this, divide by 1.5. It's been exactly 5 hours. All right. So it's 5 hours since death. So we took their temperature. The time was taken at 12:05. Go back 5 hours. That's 7:05 a.m. is our approximate time of death. So one more example says 11:55 p.m. is when we were taking the temperature. Their temperature was 92.0. So we take 90.4 minus 92.0. We get 6.4. Divide by 1.5. So you get 4.25. So again, we know it's 4 hours, but 0.25 means 0.25 or 1/4 of an hour. 1/4 of an hour is 15 minutes. So that'd be 4 hours and 15 minutes. 4 hours, 15 minutes. So it's 1:55 when we took it. Go back 4 hours and 15 minutes, and it's 7:40 p.m. Little hint, especially as the hours get higher and higher, like if you get like 9 hours, like that's kind of hard to think in your head and count on your fingers. So what I do when I'm doing these is I draw a clock on my paper, and it makes it way easier to count back. If you just draw a little clock, it makes it way easier than trying to think about it in your head. Okay, a couple more things. Just 2 slides? Yeah, so just 2 more slides of things we could do to tell time of death by looking at a body and autopsy. So stomach and intestinal contents. Time of death can be estimated by looking at the digestive tract and its contents. It takes about 4 to 6 hours for the stomach to empty its contents into the small intestine. 12 hours for the food to leave the small intestine and go into the large intestine. 24 hours from the time a meal is eaten till all the undigested food is released, meaning you go to the bathroom, and you're from your large intestine. So the location of food in the digestive tract helps us know how long the person has been dead if we know when they ate their food. So if we have a husband who's like, he was at home, he ate dinner at 6:30. His wife said he left to go pick up something from the store at 7. He's eaten at 6:30. He leaves at 7. He doesn't make it back. They find his body later. So he's been murdered. They know he ate at 6:30. When they find his body, he still has food in his stomach. Well, that means he was killed from 4 to 6 hours after eating, which was at 6:30. So from 6:30, we have 7:30, 8:30, 9:30, 10:30, maybe 11:30 if it's in that 4 to 6. So probably 11:30 and down, he was murdered in that time frame because he still had food in his stomach. All right, changes in the eye. So following death, the surface of the eyes dry out. If the eyes were open at time of death, a thin film will appear on the eyes in 2 to 3 hours. If the eyes are closed, it takes about 24 hours for this film to appear. So you can see the film here. So if they die with their eyes open, so you come in and their eyes are already open. If they have the film over them, it's been at least 2 to 3 hours. If their eyes are closed and you peek inside and they're not filmed yet, well, it's been less than 24 hours since they were killed. Now, if the eyes remain open, so if they die with their eyes open, if their eyes remain open, the areas of the sclera exposed to the air dry out, which results in a first yellowish, then brownish, blackish band, like the discoloration zone called a tache noir. Okay, so it makes this little line across their eye. It generally is seen 3 to 7 hours after death and can disappear altogether a day or so later. So basically, if you can tell from other parts of their body they've been dead for at least a day, so other things are telling you it's been longer than a day, and this is gone, then you could assume it's been longer than 24 hours because the line is gone. If it's still there, then 3 to 7 hours. Okay, so or really just anywhere from 3 to 7 hours after, but less than a day. If it's not there at all yet, but their eyes are open, then we're probably in that 2 to 7 hour window since they died. Okay, so lots of things you can take, like what do their eye looks like? What is them in their intestines? What is their rigor mortis status? What is their algor mortis? What is their temperature? What is their coloring? So you can put all those pieces together and come up with a pretty good, clear time of death. Okay, there we go.